Welcome to Naked Reflections, brought to you from the Wolf Institute. I'm Ed Kessler, and each week I'll be taking an in-depth look at the stories reported by our friends over at the Naked Scientists. What does the latest scientific stuff mean for the rest of us? Stay with us and find out. No apparent or claimed evidence in any field, including history and chronology, I'm quoting now, can be valid if it contradicts the scriptural record. This is one of the protocols of the Creation Museum in Kentucky in the United States, run by Answers in Genesis. AIG is their acronym. The museum demonstrates that the Earth was created in 6 24-hour days about 6,000 years ago. It reminds me of Archbishop Usher, who in the 17th century identified the beginning of the world as 6 o'clock on the 22nd of October, 4004 BC. AIG have also built an associated visitor attraction called Ark Encounter, a theme park with a full-size replica of Noah's Ark at its centre, and visitor numbers are high. Research from the Pew Trust has revealed that 35% of Americans believe that evolution did not take place. But here we are, on Naked Reflections, taking a long view of evolution. The Naked Scientist had a Q&A on the subject recently, and here's Chris Smith with some thoughts about how genetics and evolution might work together.
One thing maybe we could raise here is that the genetic code is universal, isn't it? So the genetic code that runs in, say, a jellyfish also works in a human. So if I took a jellyfish gene and put that into a human cell would understand that genetic message and make the jellyfish gene. And people have made glowing green mice, for example, doing that, haven't they? So is it not theoretically possible that given jellyfish predate dinosaurs in evolutionary terms, dinosaur genes, if we could get them, you could insert them into a human cell. It would understand them, but whether it would make anything useful, that's a different question.
Yeah.
With me to discuss the question of evolution are Dr. Charlotte Kenchington, a fellow of St Edmund's College here in Cambridge, Dr. Tobias Müller, a research fellow at the Wolf Institute, and Dr. Alexander Massmann from the Faculty of Divinity here in Cambridge. Now, Charlotte, I know you're a paleobiologist. Perhaps tell us a little bit about that and how that links into this question of evolution and the dinosaurs and so on.
So I'm a paleobiologist, which means that I look at fossils all day. And so for me, fossils give us a glimpse into the past that we can't get through any other means. So it gives us the preserved remains of animals that were alive at some point and are now extinct. And so not just animals, of course, plants, fungi, all sorts of things. And they tie in really well with genetics. So they allow us... So there's something called the molecular clock, which is a predictable rate at which genes evolve. And so the only way that you can constrain that clock is with fossil data. Otherwise, you need something else to support the models that you have.
And why do you think so many people, not just in the United States, find it difficult to accept this incredibly long history of evolution? I mean, you're going back how many millions of years?
So the fossils that I look at are about 560 million years old. So to put that in context, dinosaurs went extinct about 65 million years ago.
So it's a huge period of time, but many of us do find it difficult to accept that. Why?
I think it's just very, very difficult to envisage, and particularly if you think about the way that our Earth is today and try and imagine it in a very, very different place with dinosaurs running around, or even when there was nothing on land, when land was just, a sea of sand and rock. I think that's very difficult to imagine. It's appealing, but it's difficult.
In the museum, there is an image, AIG, of children petting dinosaurs. Very beautiful, very different from Jurassic Park, Alexander.
Yeah, well, that's, of course, in part, it's exciting and entertaining, perhaps. So I could imagine that would be a factor. Maybe we wouldn't even need to assume that everybody who visits the museum denies evolution. I'm not sure. But why is it that people have such a difficult time accepting evolution? I think one of the more interesting factors would be the question, how about human dignity, the special status of humans? So sometimes there are slightly provocative evolutionary thinkers who say, well, humans are just animals. We can breed them the way we breed animals, and that's what's been going on for millions of years. So is that actually a valid critique of evolution? I don't think it is.
How do we handle the literal interpretations of some of our scriptural narratives of creation?
That's a funny question, because I don't think literalists really are looking literally at the text. So if you take one of the very prominent creation stories, Genesis 1, at the very beginning of the Hebrew Bible, you would read how first God creates light, and then a couple days later, God creates the sun. And of course, these authors knew that the sun is our source of light. Perhaps there's the moon as well, but that's created even later. So there's always already a hint in these traditions that a little more is something is going on, and you never have it all sewn up. So I think what we call literalism is an unfortunate attempt to sort of insulate yourself from the living tradition that could bring up new questions.
And I guess the problem is also that literalism carries with it a certain claim to the real truth, like the real word of God. And then the argument often would be, but wait, do you think actually what's in the Bible is wrong? Like certain that, of course, as a believing person is very hard to claim. So I think it is important to, as you say, remember that any reading of a text is necessarily a interpretation. It is a way of reading it. And even the so-called literalists, and even those that claim that there's only one meaning, this is only one interpretation, and it cannot be otherwise. And every scholar of text, of literature, and most scholars of religion, actually, I think nowadays agree that what we need to do is interpret them. And that, of course, then raises the question of where are we coming from, what are our interests, and why do we think this particular version is true?
Personally, I think that evolution has brought us to a vantage point where our social instincts resonate with a wider theory, a theory that isn't determined by the evolutionary fact, but that we hit upon, and that just makes really good sense with our evolutionary heritage.
So there is a really strong evolutionary benefit to altruism, which is the word that we use for to describe taking care of people, taking care of your neighbour. And it's that if the goal of evolution, if you like, is to try and make sure that your genes survive, that they pass on, then if you take care of somebody else who has the same genes as you or is likely to have some of the same genes, then there's more of a chance that those genes will make it forwards. And there's also, with some animals, there's a kind of quid pro quo. So it's altruism with the expect of I'll take care of you, and then when I need it, you take care of me. So there is a strong, very simple evolutionary benefit to that.
Right. And then part of the interesting thing is, so we don't have to play off niceness, so to speak, in evolution against competition. So competition still plays a role, I think, in evolution. But for example, conflict is bound to arise in a chimpanzee population. And that's why even chimpanzees take care not to let violence erupt. So a leading chimp would sort of settle conflicts like that. So it's not, it's either niceness in evolution or nature red in tooth and claw. It's a really fascinating subject.
And it's interesting also what kind of different elements or ways of dealing with these conflicts have been found. If I'm not mistaken, bonobos in particular actually, I think, use a lot of kind of physical affection and love and even actually having sex to kind of release tensions within a group. So there seems to be also different models of how certain societies, animal societies, deal with that. Like either the more hierarchical model, if you want, or kind of a more horizontal, mutually exchange of physical intimacy model.
I'd like to return to the question of human dignity. I think what evolution tells us and what's changed about our understanding of human dignity.
The understanding of evolution has changed. It's not entirely clear how Darwin thought of it himself all the time. But one of the legacies certainly was social Darwinism, where people said, let's just regard society the way we would regard some animal population and let those pressures and the competition play itself out. I don't think Darwin was of that persuasion. He sometimes wrote things that would speak against it. But as we just said, it is natural. It seems to be in our mentality, in our makeup, also to care for our neighbor. So it would be a really one-sided view of evolution simply to pit one animal against the other.
And I think at the end of the day, it is also a political interpretation, which we see in how Darwin's theory has been taken up. Because on the one hand, you can make social Darwinistic arguments for kind of laissez-faire state capitalism and competition, and thereby actually morally condoning as well that the strongest and the fittest actually gain more wealth and status. On the other hand, for instance, the political theorist Peter Kropotkin said, actually through cooperation you might get an advantage in the struggle for survival. So the fittest in the Darwinian sense, and as you said, Darwin is actually open to that, might very well be those that actually collaborate, that actually create very inclusive and more egalitarian systems of support. So at the end of the day, it also very much depends on the political ideologies that one is coming from as well.
I wonder if we could bring it back, yes, Charlotte, to 650 million years ago. If you could.
So that's a really good point, and that's a really interesting way of phrasing it. And I think that's part of where the difficulty that people have with accepting evolution comes in. So evolution is a fact. You can watch it, you can detect it in the fossil record, you can study it in plants or in model systems of flies. But I think the difficulty is the theory of natural selection, and it's this survival of the fittest, and that really conjures up this image of nature red in tooth and claw, of people fighting and of animals fighting, and then of the fittest being the strongest or the biggest. But there absolutely is this potential for the fittest being those who are better able to cooperate, to share resources, and to do something like raise children collectively, which is a much better use of resources than competing to kill off your neighbour's offspring, for instance.
Tobias, you've been researching strictly orthodox religious communities across different faiths. And I mentioned the museum, of course, at the beginning, which represents one aspect, if you like, of strictly orthodox, or one part of it. But what have you learned in terms of those communities and their attitudes towards questions of evolution and, dinosaurs 65 million years old and so on?
So I would say the question of evolution certainly is one of the most heatedly debated questions among religious groups, and this goes from, I'd say, very strictly observant Orthodox groups to even more liberal groups. Kind of the question: how does religion and faith relate to science? I believe the main problem here is that evolutionary theory, as they see it, poses a question or a challenge to where does truth come from, and particularly an explanation of something that many religions, particularly the Abrahamic faiths, have a very clear record in their scriptures. So there is a story of creation in the Holy Scriptures. So if there is an account that explains or tells us a story about how all this happened, how the earth and life came into being, as it were, that might challenge that account. And so there's the question, okay, we have these two different accounts, how do they relate to each other? And there are many different ways to deal with that. On the one hand, some people say we have to take it so literally, and if it says in the Bible it was, 6,000 years ago, whatever the claim then this is the word of God, and hence this has to be absolute truth, and all other claims have to be somehow wrong. However, there are many different ways to deal with this question. Actually, going back even further than Darwin, for instance, the great Islamic scholar Ibn Khaldun, in his Muqaddimah, the prolegomena or introduction, said that probably in the beginning there were certain forms of minerals, and then they developed into palms, and then animals, and then monkeys, and then actually human beings. So this was in the 14th century, I believe. So there was a sense that there has been a change and a gradual change, which in no way contradicts the fact that God created life.
You're listening to Naked Reflections, and my guests this week are Charlotte Kenchington, Tobias Müller, and Alexander Massmann. Of course, there are other ideas about how life originated And here's Milton Wainwright of Sheffield University speaking on The Naked Scientists.
Now, my view, the one I'm working on, is that life came from space, so-called panspermia. Now, panspermia means seeds everywhere, so the idea is the cosmos is full of life, and it floats around, or it arrives in meteorites, and when it hits a planet, life is delivered there. So it's opposite to the kind of general chemical theory, which most scientists believe in, the idea that life originated on Earth. So we're saying that life does not necessarily, it could have done, that is, originate on Earth. We think life came in from space, and it continues to come in from space as we speak.
Alexander, any thoughts on that?
Well, I think it's really fascinating to see how scientists are now coming up with more and more planets that could be candidates for a stage for life. So supposedly there are even millions of planets in the Milky Way that orbit their star, much like the Earth orbits the Sun, etc. So as a theologian, I have to say I'm neither for panspermia, the idea of life originating elsewhere, nor am I against it. It's a scientific question on which I have no special expertise. So personally, I see life as God's creation, and we can describe that as a natural process. So the chemical compounds of life have to fall into place somewhere. And for me, it doesn't make a difference if they first did that here on Earth or elsewhere.
So if we discover aliens in outer space, which we seem to think exists, that wouldn't affect your understanding of the divine?
No, I don't think it would. So first of all, I think it's really quite fascinating to see how scientists make a case that there probably is life elsewhere in the universe. And then you could extrapolate from that, well, if there's life, how likely is some sort of social society to develop, animal intelligence and those kinds of things? I'm not entirely sure how likely it would be, say, for something like religion to evolve elsewhere. Can we give an evolutionary account of religion?
I think it's an interesting question whether religion is part of the evolutionary cycle. Tobias?
Yeah, certainly. I guess kind of in the beginning of people trying to understand religion, not from a theologically, but more from an anthropological perspective, actually, evolutionary theories were very strong. So the idea was, in the beginning, there was myth and mythology, and that then or magic, and that gradually transformed to proper organized religion that rationalized, and eventually then during the Enlightenment, science set in and kind of replaced religion. So these evolutionary accounts, certainly do exist. At the same time, one can also conceptualize religion as dealing with transcendence, but transcendence not only in the sense of there being an entity that has supernatural powers, but the things that are beyond that which is directly graspable with our senses. And in that sense, we experience transcendences all the time. Even when we sleep, actually, can be conceptualized as a transcendence. We go into a space that we cannot feel or can't really conceptualize. Or if we think about our ancestors, like somehow there is a certain transcendence that we are somehow connected with them. And that, of course, is a very important element of religion. There's one theory that says religion is basically a chain of memory, like connecting to certain pasts, to traditions, to spaces, to times, to narratives. And so in that sense, I would argue it is not unreasonable to believe that wherever there is life and sociality, some form of religion or transcendence or dealing with transcendence might emerge.
And I think transcendence is also part of the academic story, the search. When you discover something or uncover something, as if something changes, which is part of the religious story. I'm just wondering, Charlotte, whether in sort of your studies, whether you've had those moments, I'm sure you have, when it's like a eureka moment, but it's almost a religious, transformative moment.
I'm not sure I describe it as being a religious or a transformative moment, but there are, so the fossils that I work on, so they are the oldest animals that we know of, and the way that they're preserved, particularly in Newfoundland, in Canada, which is my main field area, they're preserved as almost snapshots of the seafloor that were buried under volcanic ash. So they lived in very, very dark oceans at the bottom of the seafloor, and then they were killed by a volcanic ash flow coming in and smothering them. And then this volcanic ash is, we think, quite important in preserving them, but it also weathers more easily than the surface on which the organisms were living. And so when you walk up to one of these surfaces, you see the ancient sea floor with all the fossils laid out in front of you. And it's one of the most spectacular things that I've ever seen. And then you get it on a sunny day and the light's just right. And that is almost spiritual. You're getting this really privileged, unique view into a community that has been dead for 10 times as long as the dinosaurs.
So you're part of that process, aren't you? You're engaging in it not simply in an academic sense of the pursuit of knowledge, but there's something beyond that.
Yeah, there's definitely a thrill to discovering. So whether it's discovering a new species or discovering a new fossil site.
So you are very much working in the beginning of the evolutionary cycle, if it's fair to say, 650 million years ago?
So not the beginning of the evolutionary cycle, but the start of when we have complex multicellular life. So there was approximately 3 billion years before that of purely microbial life. And this sort of has a bearing to what we think about life evolving on other planets. So it's comparatively simple to make a cell. So fat molecules, the way that they arrange themselves, make a little ball. And there have been a number of experiments, the classic one being the Miller-Urey experiment, shove some lightning into what we think primordial atmospheres would be like, and you get amino acids and all sorts of things. It gets more difficult when you try and make a cell like a eukaryote cell, which is not just a bag, but it's a bag containing lots of other bags. And the way that we think that happened is that you have something like an amoeba, so a fairly simple bag, and then it starts to envelop other bags, if you like. And so you can see evidence of that in sort of the double-layered walls that you have of mitochondria, and also in the genetics of mitochondria. So that's the bit within our cell that generates the energy for us. The genetics of mitochondria are very similar to some bacteria that we have that still exist as bacteria. And then when you start to become multicellular, that's almost cooperation itself. So coming back to that idea of cells cooperating. So you can do much better when a load of cells come together. You can reach higher into the water column to release your spores, your offspring. But then at some point you become obligatory multicellular. So we can't shed ourselves into a load of single cells and then come back together, but sponges still can. So there are a number of steps that take you from becoming a simple bag of chemicals to being a complex multicellular being, and then let alone consciousness and neurology and all the crazy stuff that goes on in our brains. On the balance of probability, you have life on other planets, whether or not that's intelligent life or life that is social or life that has neurological networks that are complex enough to allow us to be conscious and therefore to develop really complex concepts like religion or science. I think there are so many steps that the probabilities just become vanishingly small.
So, Alexander, where do we take that now? How much further have we got to go in the evolutionary cycle? Is it never ending?
What might humans evolve to? Well, what humans are especially good at it would be what one could perhaps call cultural evolution. Probably biological evolution continues with maybe people no longer having a wisdom tooth or those kinds of things. But that doesn't, I don't find that particularly spectacular. Cultural evolution is really interesting, but those are never-ending possibilities.
But I think what's important to reflect on also is the notion that evolution often carries with it as something either positive or it's something inevitable into a certain direction, or there's a certain teleology to it. And I think a lot of the developments actually are not necessarily negative or positive in either way. And I think the important question is also to think about how processes that are more of a degeneration maybe, or actually where something gets lost along the way, how do we conceptualize those? And the second question, how do we conceptualize ruptures, revolutions, things that are unanticipated? And I think this is particularly important when we try to imagine maybe one of the most important evolutionary questions, if you want, the question of climate change. Because Amitav Ghosh, in his book The Great Derangement, for instance, makes the point the problem is that we cannot really fathom, we can't really imagine, we can't really think what climate change means in terms of the time spans. That's why I think it's really interesting what Charlotte is doing, actually like taking this deep time, these very, very long time frames into account to imagine that actually what might happen next, i.e. in the next 50 or 100 years, might be a quite radical rupture from what we've seen in the last 200, 300 or even 2,000 years actually. So the question for me is, are we maybe actually settled in a mode of evolutionary thinking that there will be only gradual change, and accordingly our politics, our culture will also develop step by step, bit by bit? Or actually, are we actually at a point where a radical change will happen rather sooner than later? And I think that is the case with climate change, but we are unable to really grasp it culturally, maybe also religiously, philosophically, certainly politically.
So with climate change particularly, we have examples of really dramatic climate change in the rock record. And the difficulty there is that, as far as we can tell, it's happening on a much slower timescale. There are uncertainties with geochronological techniques, so dating the rocks. But as far as we can tell, it isn't happening in the rock record as fast as it is today. And so this gives us the idea of a perturbation. The question of punctuated equilibrium or gradualistic change or punctuated evolution has been a really long-running question in evolutionary theory. In order for ecosystems to respond to climate change as rapidly as kind of we would maybe want them to mitigate some of the problems that we as a global society have induced, it would have to be a really, I think, a fortunate coincidence for some fundamental change in genetics to allow ecosystems and even just individual species to respond as quickly as we might want them to.
Well, I think we have evolved to the end of this podcast. Thanks to my guests, Charlotte Kenchington, Tobias Muller and Alexander Mastman. And thanks to you for listening. If you'd like to get in touch with any comments, thoughts, feedback or reflections of your own, you can email reflections@nakedscientist.com. In the meantime, you can find more episodes of Naked Reflections and subscribe to the Naked Reflections podcast at nakedscientist.com/reflections. Do join us next time.